Our next track is called Null. Tranquility, equidistantiated, immobility, silence, fall materialization, silence. What does this all mean? What are we doing with this track? So what you're hearing in this track is actually notes with a wavelength that corresponds to sums in the digits of pi. So here I've shown you a table of the notes playable on a piano, which are in black, A0 to C8. Here's the frequencies in hertz, and here's the wavelength in centimeters if we assume a speed of sound of 343 meters per second.
And I think we all do assume that.
And we do all, well, it depends on the temperature. So we're playing in a reasonably temperatured room.
What's the temperature? Is it
I think this is
degrees?
No, I think this might be 20, but or 22. It's a yeah, I can't remember. And this is tuned so that I believe A4 is 440 hertz. A4 or A3?
A4. Yeah, A4.
Yeah, is 440 hertz. And the frequency doubles every octave, and so that the frequency ratio between adjacent semitones is the 12th root of 2. If we do this 12, multiply this 12 times, then we get a factor of 2. And so where this table comes in is in how we interpret the digits of pi. We use 0, much like we use 9 to delineate the digits of pi in the Feynman point, we use 0 as a delineation. So there are 32 digits before the first 0. There are 17 digits after the first 0, before the second 0, 3, 10, 5, 5, 7, and so on. What we do is we take these digits, we add them up, and we'll get 155. And then we also create two smaller sums. The first half of the digits, 80, and the second half are 75. We take this number 155 and we think about it in terms of a wavelength in centimeters, and A4 has a wavelength of 80 centimeters and A sharp 4 has a wavelength of 75. So we play the first group of digits as a chord, A3, A4, A sharp 4. We play the second group of digits as a chord, F sharp 4, A5, E5. The third set of digits is a very short set. It's 582, and it only adds up to 15. So that's playable. D7 is still on the piano, but a wavelength of 5 is outside of the register because C8 has a wavelength of 8 centimeters, and a wavelength of 5 is like a G sharp 8. We don't have that on the piano, so that note is not played. A7 is played, and that is this note here, which is close to 10. In the case where none of the notes are playable, for example, if there is a 0, 1, 0, and that is a wavelength of 1 centimeter, that will be a rest. So when we look at this score, we're kind of reminded of the 314 score as well, but there's something that's also missing, which are the ends of the notes or the stems of the notes. Yeah. What's happening here?
So this is another piece which we kind of reverse engineered. So I am a big fan of Morton Feldman's work. His music has this kind of still, peaceful kind of quality. It's always very quiet, and it doesn't have this kind of linear sense of narrative. It's not telling a story. It's not pushing you in any kind of direction. The music kind of exists, and you kind of approach it on its own terms, or not. You don't have to listen to it. And that's that.
We haven't made listening to this album compulsory yet.
No, not yet.
It's
not mandatory.
Yeah, it is not mandatory. You have a choice. You always have a choice.
So this idea of like referencing null or the zeros kind of made me think of the Morton Feldman. And so the Feldman's music is characterized by a soft dynamic, and also it's arrhythmic. It doesn't want to give you a sense of movement so much. This is about stillness and clarity. So you can see that we've got these pitches, or these chords here that are built on those pitches that Martin was talking about. What is that? A3, A4.
So we have that A3 down here, which is 155 centimeters.
Yeah.
And then here we have the A4 and A sharp 4.
Yeah. So this piece moves at a very slow tempo. The marking here is immersed, so the idea is to kind of get lost in this kind of sound.
And there are no stems on the notes.
Yeah, we want to avoid any kind of sense of rhythm for this. It's just kind of pitch cluster after pitch cluster.
Pitch cluster.
Yeah.
That sounds a bit like a disaster, but that's a term that's safe for work.
It probably postdates Morton Feldman's career. One thing that I just wanted to point out is that because of the way we've constructed this, these pitch clusters, some of them have these tonal characters. So some of them are like actual minor, major sounding chords. That is something that Feldman would have avoided. His harmonic language was more abstract than that. And I think that's an interesting thing that arose from the way that we constructed this piece, is that, there is this kind of element of tonality and chords, traditional harmony that's kind of built into this piece.
And once in a while, you see a clef popping up that tells you to switch clefs. And and how did you decide to end it here?
That is a really good question, and I can't remember the answer to that.
Excellent. Well, the music remains a mystery for everyone. There was a limit in terms of time, but this is a long track.
Why did we stop there?
Why did we stop there?
Why did we stop there?
Yeah.
I'm not sure.
Oh. Well, perhaps...
There doesn't have to be a reason for everything, Mark. I just felt like it.
This is a lot of times I get this as an answer. There's not a lot of reason.
So this,
maybe you guys can think of a fitting end that perhaps comes a little bit sooner, or continue playing, and then when you feel a sense of resolution, which in some way is contrary to the nature of the piece, that there should be no resolution. So there should be no reason why it ends at a particular point.
We could have started this piece. It starts at the beginning, so it doesn't. But we could have finished the piece. ... Like it could easily continue on ad infinitum.
It's Feynman speaking.
So for me, I was mentioning in a conversation that we had earlier this week, this piece is the most representative of the idea and the concept of pi. Pi isn't random, from what I've learned from Martin. Is that right?
No, it is. It is thought to be normal in the sense that,
what does that mean?
Within every sequence of pi, every subsequence of pi, the digits are uniformly distributed, and the likelihood of seeing any digit is equal. But to say that pi is random, well, it can be used as a source of uniformly distributed random numbers, I guess.
Right.
Although you just always get the same one, so I guess it's kind of like a seeded pi.
Yeah. So I guess in my very layman kind of terms, I would characterize this piece as just kind of existing in a space where it doesn't, it's not pushing the listener in any kind of direction. It's not telling a story or a narrative. And me, personally, I kind of relate that to the sense of the random distribution that pi is, I guess. And I think the fact that this is based on like a physical quality of like wavelength, I think that's a really kind of exciting aspect to this piece. Yeah,
so you're hearing uniformly distributed wavelengths, but because the ear is not linear in the way we interpret wavelengths,
right.
the higher the notes, the more notes of the same pitch difference sound closely together. There is a bit of a psychoacoustic way in which the distribution is interpreted or reinterpreted.
Yeah. So I hope you enjoy this piece.
I hope that it immerses you.